Hello and welcome to the Ratios and Proportions video for Math 6. Today I would just like to inform you or remind you of your pause button. If ever you need to finish writing some sort of notes or you're going to practice a problem before I solve it, remember just hit pause and then unpause to join back in. That's the beauty of being able to work online via video because you're able to pause it. Today in class, we were able to talk about rates and ratios and proportions. And we talked about the fact that a ratio is how I compare two values. A ratio compares two quantities. There are different ways to talk about a ratio. When I compare two quantities, it could be the number of students in the classroom. I could be comparing boys to girls. It could be the types of fruit in a basket. I could be comparing apples to oranges. I could be comparing different colored marbles inside of a jar. There are blue marbles to red marbles. So a ratio compares two separate quantities. There are different ways to represent these comparisons. We are able to represent them as part to part, which is kind of what I described with the fruit and the kids. Boys to girls would be part of the class is boys, part of the class is girls, so part to part. In the fruit example, it was also part to part. Part of it was apples and part was oranges. I can compare it part to whole. In this case, for the boys and girls, I would be comparing boys, part of the class, to the whole class, the boys and girls all added together. In the fruit example, I'd be comparing just the apples to all of the fruit inside the basket. So there are different types of ratios. We usually will only deal with these first two, but the bottom kind might pop up as well. And that just switches the order in which we talk about it. How many total parts are there? Whole is there compared to the part. When we write ratios, we write them in three ways. You haven't realized it, but you've actually been dealing with ratios for quite some time because a ratio is simply a fraction. However, I can also write ratios with the word to, comparing a number to another number. I can compare them with a colon, so I can compare A colon B, or as the fraction, A over B. So let's look at one of our examples here. Let me see if I can move this line. There we go. Write the ratio of boys to girls if there are 16 boys and 19 girls. This problem is actually fairly easy. The key is to pay attention to the order of which it says. This says to write the ratio, so I'm choosing one of these three methods, ratio of boys to girls. So I need to write boys to girls. Now, I can't just write the words, obviously. I need some numbers in there. So let's go do some investigating. As I do some investigating, I find that there are 16. Oh, it didn't change my color option here. I find out there are 16 boys. So I'm going to put 16 down for the boys. I find out that there are 19 girls. So I'm going to put 19 in for girls. Then I can write it like this. That is one way to write this problem, 16 to 19, boys to girls. I could also then write it as a fraction, 16 over 19. That would be option right here. Or with the colon, 16 colon 19. All three of those are the correct answer. I finally want to double check to see if they need to be simplified or reduced, and as I look at these, nothing goes into both of these. They don't share a common number, probably because 19 is prime. So those problems are completed. One of those three answers would be sufficient. All right, let's look at an example here, kind of a word problem table to follow. We have a few questions that we have to solve. Question number 1 is not this question, it's this one, so I'll move this one out of the way. Question number 1 says to write the student-teacher ratio of Prairie Lake Middle School as a fraction. So, a few things. I want to go to Prairie Lake. Prairie Lake is right here. I need the number of students and the number of teachers. This says to write student to teacher. So student number comes first. I look here, my student number is 396. To teacher is 22. That's one way to write it. Another way to write it would be 396 over 22 or 396 colon 22. Now there's a problem with each one of these. As your teacher, I would have to mark them incorrect. The first thing that should pop into your mind is the fact that all of these are even, so they can be reduced. So 396 over 22 can be reduced. They're even, like I said, so I know at least 2 goes into both of them. So I can divide both of these by 2. This will give me 11. If I divide this by 2, it's going to give me 198. I believe that's it. Let me think for a second. Yeah, I'm pretty sure that's right. And then this one's a little bit tougher for you because it's not something that pops into your head right away. But I see that neat anomaly with the 11s, that these 2 outside numbers would add up, and it's 18, and they add up to be the middle number to be 19. So I can tell that 11 goes into both of those, and my final answer would be 18 over 1. If you didn't notice that, just try taking your calculator and see if anything else could help this reduce. It's always worth trying to see if the 11 would go into both of those. But what I was just able to find here is that at Prairie Lake School, it won't let me write up there, it's skipping right now. At Prairie Lake School, I have 18 students for every 1 teacher. 18 students for every 1 teacher. All right, let's see how to do this one. Oh, let's see. I'm going to have to erase all that. There we go. Let's try the next one here. Which school has a lower student-teacher ratio? We already know that Star Prairie has 18 to 1. Prairie Lake, I'm sorry. Star Prairie is a city over in Wisconsin. So we know that Prairie Lake has 18 to 1. Now let's try Greenbrier. They have 510 students to 30 teachers. Well, I'm going to start each of these by dividing by 10 as a way to reduce. And I will get 51 over 3. I know that 5 plus 1 is 6. And since 6 can be divided by 3, the whole number can be divided by 3. So I'm going to divide both of these by 3. And I find out that this is 17 over 1. So I find out that Greenbrier has a 17 to 1 ratio. So which school has smaller class sizes, theoretically? And in this theory, Greenbrier would. But to write the ratio, all I did was just write the fraction and then reduced it, and I was able to compare. We're going to skip the brain break. All right, so let's go to a problem here. We've got some Greek-style seasonings that we need to make. And in order to do that, we need to compare some of the ingredients. I'm going to hide these for now because we're not doing those quite yet. Let's read right here. It says, write a ratio to compare the amount of garlic powder to the amount of dried oregano. Again, it's as you read it. What comes first is garlic powder. What comes next? Dried oregano. So I'm going to go over here and I see 4 teaspoons of garlic powder. Garlic powder comes first. So I know that down here I'm going to have 4 teaspoons. And I'm going to compare that to the amount of dried oregano. And if I come back up here, I see that dried oregano is 6 tablespoons. So compare that to 6 tablespoons. Here is my ratio. I'm comparing the two. I'm going to write it as a fraction, 4 tablespoons to 6 tablespoons. And then I notice since they are both even, they can be reduced. So I'll divide both of these by 2. And in reduced form, I will have 2/3. So my ratio of garlic powder to oregano is 2 to 3. Every 2 tablespoons of garlic powder I put in, I have to put in 3 tablespoons of oregano. All right, let's try another one. What I'm going to do is I'm going to clear these, and I want you to pause and try solving these. And once you have an answer, come back, try B, and try C, and see if you're right. Go ahead and pause now. Welcome back. All right, so hopefully you were able to try these. You were able to read pepper to garlic powder. You came up and hit 2 tablespoons for pepper and compared that to the 4 tablespoons for garlic powder, and you were able to find 1 to 2. For every 1 pepper I put in, I had to put in 2 teaspoons of garlic. Same thing for oregano. Well, different answer, but same idea. Oregano, I looked up here, was 6 tablespoons to pepper was 2. Again, both of those can be reduced, and it was 3 to 1. Hopefully you were able to find those same answers when you solved. Sometimes we're going to need to determine if 2 ratios are equivalent. Equivalent, remember, is just a fancy word for equal. So I want to know, does this ratio equal this ratio? You have 3 different ways that you can write a fraction. You can write a ratio. 3 different ways to write a ratio, and one of those ways is as a fraction. So I'm going to take this very first one and write it as a fraction. 250 miles in 4 hours. I'm going to reduce that. I notice here that at least 2 goes into both, and if I divide both by 2, I will get 125 over 2. So I know that these 2 are equivalent, they're equal because I just reduced it. Here's this other set of a ratio. It's going to be 500 over 8. 500 miles over 8 hours. Again, I can divide both of these by 2. That's going to give me 250 over 4. If I divide by 2 and divide by 2, I already see something, but let's see if you see. I'm going to divide by 2 again, and divide by 2 again gives me 125 over 4. So this was the 500 over 8, and this was the 250 over 4. They are equal or equivalent. So yes, those work. Go ahead and hit pause again and see if you can solve this one on your own. Welcome back. Hopefully you were able to set up 2 ratios. 20 nails to 5 shingles. If I was to reduce that, I would get 4 to 1. And on this other problem is 12 nails for 3 shingles. And if I reduce that, I got 4 to 1. And so yes, they are equivalent. They equal each other. Try one more, like this one. Go ahead and hit pause. All right, welcome back. So in this case, I'm comparing flour to sugar. I have 2 cups of flour to 8 cups of sugar. And then here I have flour again. That's going to equal 8 cups of flour to 14 cups of sugar. So I shouldn't have written these so close together. So I need to know, do these 2, are they equivalent? Is 2/8 the same as 8/14? So 2/8 I know can be reduced by 2, so I will do that, and I will get 1/4. And 8/14, they're both even, so they can be reduced by 2, and I will get 4/7. And this can't be reduced anymore. Does 1/4 equal 4/7? Obviously not. So these are not equivalent. All right, so that is how you can solve some of those. Last but not least, my time is running up here. I have about 52 seconds. Let's try a word problem. Derek Jeter of the New York Yankees had 32 hits out of 93 times at bat. So the first question I'm going to ask myself is, what am I comparing? Well, I'm comparing the hits that I had, 32 hits, to the 93 times at bat. So I am going to have 32 hits to 93 times at bat. This other guy, hits to times at bat are 11 to 31. See if these will reduce at all. I notice that both of these, if I add them up, that adds up to a 5. This adds up to 9, 10, 11, 12. So this 3 would go into this, but not into this. Does this reduce at all? I don't see anything that goes into these two numbers to make it reduce. So I would guess to say that these are not equivalent. Some of you may have noticed that if I times by 3, I would get 93, and if I times by 3, I should get 33, and I don't, so it's more emphasis that it's not equivalent. And last but not least, if I had this number and I tried to say they were equivalent, I can do something that I mimic as up, up, and away. 93 times 11, 31 times 32, and if you take those and multiply them out, you're going to notice that you do not get equal numbers. You'll get 992 right here, and on the other side, you'll get 1023, and those two numbers do not equal. So if for some reason you can't reduce it, you can multiply, cross-multiply, and find the two numbers to see if they do. Thank you so much for watching, and I hope this helps.